Hey guys, so I wanted to talk about something that I have been fighting since the day I've thought about building this rig, and that's thermal bridging. If you don't know what thermal bridging is, essentially all it is heat loss, typically through a conductor, usually like something we're building here, metal, from the inside to the outside. And all that means is in a normal wall, like in a house, for example, you'll have a cavity filled with insulation, a stud that touches the outside wall and the inside wall, and that stud is considered a thermal bridge because it's something solid that allows the heat to transfer, either the cold transfer in or out, or the heat from the inside out. So cold in, heat out, I'm not sure which way it goes, but you lose heat more rapidly through that than you will the insulated wall, because the insulated wall is an R19 and that stud is like an R3, 3.5, something like that. So on my rig, I came out last night and I saw these. It was like it was so cold, it was frosting up parts of the rig, and you could see where there were like these pockets of different like frost levels. Like there was a pocket and then a clear spot, a pocket and a clear spot. And I could clearly see where my studs were. I came out here with a little temperature gun and shot the different spots, and I found out there was about a 2-degree, maybe a little less, difference between the areas that are totally insulated with no metal going from front to back, inside to outside, and where the studs obviously support everything, and that's for the roof and the walls. Same difference, about 2 degrees. I want to take you inside real quick and show you what I'm talking about. So on the inside of the rig, I knew building out of metal would make things challenging to eliminate a thermal bridge. If you guys have looked at building your own rig and trying to insulate it, spray foam is a great way to do that, but inevitably, when you build this, obviously this wall has a stud and a top rail and a bottom rail just for construction's sake to keep it structurally sound. Same thing with all the walls, ceiling, roof, everything is built that way. And I used aluminum because it was lightweight versus steel, so that's a plus. So it's also metal, which kind of bit me in the butt. So what I did is I insulated all my studs, which helped but did not eliminate the thermal bridging. The other thing is I didn't want to use any wood in the build for mildew, for moisture absorption, for deterioration, for whatever reason. I didn't want to use wood in the build anywhere, so I haven't. So that limits your choices as far as what you can use on your structures. So to help combat some of the thermal bridging, what I've done is I've taken this 1/4-inch foam core and I've put that down on the studs first, and then I've put my finished material, my fiberglass reinforced panel. So here's the 1/4-inch foam core board, here's the panel on top of it. And that's how I finished all the walls down below. On the roof, I figured that the fiberglass reinforced panel was a little too flimsy and heavy to put on the ceiling. I was afraid that even gluing it, it might pop and bow at some point. So I used aluminum. It's a little stiffer than the FRP. Downside is it's metal. And I also used aluminum on the walls of the roof. And the reason for that was because the aluminum was thinner than the FRP panel. And where that matters is where the roof clears the lower wall, and actually the slide out, when it comes in, it's the edge, you can see the edge of the trim, and I knew if I had anything too thick on here, it would catch the trim. And lo and behold, so instead of using these joints, I didn't necessarily want to have this joint showing because it's below the window, so I just overlapped them, and it's about the same thickness as what this little trim piece would be. But lo and behold, I started lowering the roof, testing things out, and you can see that guy caught on the slide out, and you can see that gap right here is way less than half or 5/8, which is primarily what I have around the rig. Long story short, thermal bridging is something that I've been fighting for a long time. And I've had to compromise in certain areas, and I've done everything I thought I could to minimize it. So here's something that's pretty cool. So I was talking about last night when I could see the areas where the studs were and where the voids, the cavities were that were insulated, like clear as day. Well, guess what? It's day and it is clear as a bell. So we did get some snow yesterday, and I've had the rig at about 55, 60 degrees, just keeping the panels warm and the glue warm so things cure. And you can see where my studs are on the edges and where they go through structurally every 16 inches. And you can see the cavity with the 3 inches of foam insulation loses heat significantly slower than where the studs are. This demonstrates absolutely perfectly what thermal bridging is. And it is a bugger. Even in modern construction in houses, you don't realize it quite as much because obviously you don't see your roof with snow on it and see the rafters. But depending on how your house was insulated, if you have an older house, you may see that on your roof. Like if you get a frost and then the sun comes out, you can actually see where the rafters are in a traditional build. So there is a way to minimize thermal bridging in home construction. Basically what they will do is build a 2x4 wall that is 6 inches thick. And what they do is they have an exterior studded wall. So the studs go all the way to the exterior, obviously, and support the exterior sheeting. And then they alternate a second set of studs on the inside so that the studs are not a solid bridge all the way across the wall. All right, so I thought I would mock up a little demo real quick and show you what I was talking about, because me using my hands might not make a lot of sense. So traditional stick construction is, imagine these as 2x4s, and this is your interior sheeting and exterior sheeting. Typical construction is every 16 inches on center, you have a stud. Outside wall, inside wall are touching that stud on both sides. So there's your thermal bridge. It goes, heat is sucked out or in, or cold is sucked out or in through this. These cavities are insulated, and that insulation is what keeps your house warm, but the tremendous inefficiency is in the studs. And if you calculate the square footage of the 1.5-inch stud by 8 foot throughout your entire house, you're actually losing a lot of heat through these guys. So that's traditional stick construction. Now, I don't know what it's called, but when they stagger the studs, and I'll show you that, they decrease that thermal bridge tremendously. I know, my studs aren't the same length. Kind of a crappy house. This is for demonstration purposes only. All right, so in this type of construction, if you look down over it, you can see that each wall has its own structure, basically. So your exterior wall is its own entity, and the interior wall is its own entity. The drawback to this system is you're using essentially twice as much lumber. So it's a bit pricey to build a house this way, but the benefit, and this may be a huge benefit in the right climates, is long-term you're saving on heating and cooling the house. And this is how. So basically, in traditional stick construction, you have that thermal bridge, which you have now eliminated. So you have insulation that runs not only in the cavities, but runs around all of the 2x4s and eliminates that contact between the interior and exterior walls. So this is why this construction is such a big deal, and why, depending on where you live, it can be an expensive deal and or a money-saving deal. So if you can incorporate something like this in your build, you know, if you can sacrifice having a 4-inch wall and using 1.5-inch studs or 1-inch studs or whatever makes it work, something like this incorporated in an expedition vehicle or off-grid build could save you a ton in heating, especially for those of you guys that go into the cold climates. And it just makes things a little bit more comfortable because you don't have those cold spots where the thermal bridge is coming through. And believe me, you will probably notice them if you're camping in some wicked cold weather. So hopefully that helps, and hopefully it's clear enough that you guys understand it. If you have any questions, leave me a comment. I will do my best to answer. Thanks for watching, guys.